last physics science video, yeah, physics mostly. Anyway, physics is everything anyway, right? So I figured I'd do try to do a better explanation of magnetism and a semi-simple drawing. So first, the context. Magnetism is really hard to draw in two dimensions. I figured that out because it's really a density of polarizing filter. So it's really just about proportion. So I just did a simplified drawing to try to illustrate it, because it's difficult to illustrate the idea of two poles and then poles on the sides. You know, it's pretty complicated in terms of the density of, say, the different substance. And I'm sort of going to argue that, yeah, that's what a magnet is. It's the matter substantially has been changed. The matter on one side and the other side is aligned differently, kind of like a light polarizing filter. It's an alignment issue, and it filters gravity, ironically or interestingly, and but it does it in such a way where it doesn't create any anti-gravity, in the sense that even though it's twice as sensitive to one part of gravity and not sensitive at all to the other half, so it's the same amount of sensitivity to gravity all overall. It's just filtering gravity, and it can only filter it in this two-pole way. So if you could have a true monopole, which I think you probably can inside of atoms, so that'll help in describing the function of atoms, is that there probably is something that's truly an anti-gravity particle that isn't susceptible to certain half of gravity anyway. It's invulnerable to half of gravity, so it's living only with half gravity bothering it. But I don't think you can create a large-scale monopole, except maybe in special circumstances with cryogenic stuff and all that kind of crap. Maybe they can super freeze something and create a monopole, but monopoles aren't naturally occurring in our big universe. So my point is just that that's why there's no anti-gravity matter, is that you can't just take a piece of a magnet and break it off and have a monopole. You can't just say, oh, here's the north side, I'll just take some north side off. It just automatically creates another south, you know, that kind of thing. And as long as both poles exist, there's a net zero effect in terms of overall gravity. For a magnet, it would be interesting to be able to do some experiments on magnets outside of a magnetic field. Like, you know, we can't do that because the Earth has got a magnetic field, and the Sun has one, and you know, it's pretty hard to go somewhere where there's no magnetic field to interfere with a magnet and then be able to see how gravity actually affects it, in terms of would there be any ability to detect poles based on how gravity overall affected a magnet. So, but anyway, it's I don't want to get lost in gravity, but the important feature here is that I'm basically, I think, can say relatively confidently that magnetism is gravity filtered. That it's the same photons that make up gravity. They're just filtered by magnets. And so magnetism is a form of gravity, which is kind of a bold statement. Interesting. Just even this idea of a particle explanation for gravity, I think, would be, you know, it's a bold statement, but it works, I think, and I like it personally. I mean, in terms of it explains it. Now I understand why their magnets attract and why magnets repulse. I understand why now, because I understand there's a physical force. There's physical photons, let's say. There's photons, whether they're physical or not, who cares? And that they're, you know, doing the work, so to speak, in terms of changing the disposition of the matter they're influencing. They're passing on directional information in terms of interacting. They're not exchanging energy, they're exchanging directional information. That's why magnets do a lot of directing. Anyway, so I think that's enough of a premise. So I guess I'll go to the diagram. So again, the monopole thing is important. That's something I'll have to research. The other thing to be clear on is that gravity is really, really dense, and matter only filters out or only is affected by a tiny portion of the amount of gravity that goes through you. So maybe it's only 1% of the gravity that's possible is actually affecting you. So there's more gravity. Let's see how to explain it. It's like this is a common phenomenon in nature, in the sense that there'll be more of something than there is catalyst to use it up, and so it'll use up the like the sun does that with the atmosphere, in terms of creating scatter, and it uses up all the molecules that it can use up, and then the sun will change colors based on how the fact that it's used up all the electrons, or the specific atoms in the atmosphere. It's catalyzed all of them, and now you'll be able to see the sun in a different color because it's used up all the catalyst. So there's a high density of gravity, and it's only a tiny portion of the gravity that you're actually influenced by, the photons. So we're talking about subtle changes in pressure, not absolute changes in pressure. It's not like it's all the way on and all the way off. It's like there's a 0.0001% change versus the two sides. But because it's so dense, that slight change is a significant change based on the proportion of matter you have versus the proportion of gravity. So I'm sort of arguing that gravity is the gravitons that are in the atmosphere we exist in are incredibly thick. Like, we don't know we're in this really thick soup, but we're like in seawater. We're in a thick environment of gravity, and an inexhaustible supply almost. We don't know what its exhausting rate is. And black holes, maybe some size black hole would be able to block all of some kind of gravity, and then there would be no more gravity to block, so it couldn't gain any more gravitational influence no matter how massive it got, because it can't block any more gravity, unless it got bigger rather than smaller or something like that. What size doesn't have anything to do with how much gravity you block. It's your mass or your density. So I guess there's theoretically a shadow so black kind of an idea. See, shadows are sort of deceptive, because they are so on and off. It's like we block all the light, so we create a very dark shadow. So this gravity influence and this magnetism influence is a very slight shadow. We're dirty glass. Or we're glass that's more or less reflective. So you can get the idea that maybe it's only 4% of the light that goes in gets reflected back to the source. So it's that kind of percentage. We're being altered by a small percentage of the gravity that goes through us. Okay, just want to make that clear. So hopefully this will be simple enough, and yet you'll respect that the actual reality is going to be much more complex, because there's lots more pattern to the formation of a magnetic structure. So in this diagram, maybe I'll use a pen or something as a pointer. Doesn't really matter, I suppose. Where's my pencil? I'll use that mechanical pencil. Alright, so the idea is, okay, I've labeled these things, and so maybe you can see some of those labels, maybe you can't. I think I'll post the diagram in the video, and then maybe you'll see it all the time, and then I won't have to point. But anyway, this basically says AB and then BA. So there's two substances, north, south, however you want to describe it, doesn't matter. Just think of it as A and B. So there's two kinds of gravitons. They're polarized. And there's A polarization and B polarization. And generally speaking, gravity is a mixture of those two, an even mixture, let's say. And but for magnets, the catch is that this AB substance would be 2 times sensitive to the A. So it's 2 times sensitive to the to the A polarized gravitons, and it's 0 sensitive to the B kind. But the catch is the B kind, when they go in, it converts them into A kind. So when they leave, they're A's. And so the A's go in, they affect the, they impose a gravity, so to speak, a pressure on the material in terms of a change in its disposition, its will. Now wills to go in the direction of that because this gave influence to it. So the other thing to understand, I mean, I'm in the middle of labeling, but I'll just point it out for the sake of understanding. I'll use this little diagram up here. When gravity goes in, it likely goes in one direction and comes out another direction. So that's something else to understand. That I'm doing this for simplicity, just to understand the poles and stuff. But the gravity that would be coming out this side might be going in the top of the material and coming out the side. So there's this line is like a curve through the material. Like I said, you have to understand it's a density line, and in here the density of the material is but like I say, it curves through the whole material. So you got to understand that too. That this two-dimensional drawing can't really show you what a magnet looks like interior. So just for the sake of argument, I'm just trying to create a pole at each end just to explain why the poles repel. So yeah, so you have to understand that the field lines for magnets are basically not really field lines. They're basically, when you do this model correctly, and you put all the different angles of influence and everything else into here, what all it's really creating is areas of different pressure in terms of the proportion of A to B photons that have a vector going through that area. And that's really what happens. And so these are alignments, like say if you put a material that's magnetic in this field, it will align with this only because that represents, okay, the density of the material at that point. So that it would represent how much of a differential there is in terms of how much AB gravity there is at that point. And so it's going to align with the individual pressure as the pressure changes as you go outside of the magnetic field. The outside, I don't want to say magnetic field because I'm saying it's photons. There is no field. There's a field of photons. But the field of photons comes out as a representation of the density proportion of these two types of filter. And so, well, hopefully that's enough. Like I said, I didn't want to get into all those complexities because I just want to illustrate the basic force function, why there is repulsion and attraction. And I didn't even draw the attracting, the reversing of the magnets, but I just figured you'd intuitively understand how to reverse them yourself. But anyway, all right, so here you have the north side. Let's say this is the north pole of the magnet. So it would be 2 times sensitive to the A photons, the A polarization, and 0 to the B. So the B's go right through, but the B's are converted into A's when they go through the material. Or you could almost argue they're converted when they go across this transition between A and B. It's probably something like that, that they're converted at the transition line of the poles. But it doesn't really matter. Just for the sake of this argument, just understand they go in a B, they come out in A when they go through the north side, and they do exactly the opposite on the south pole. Okay, the A's are converted into B's, and the B's go right through. And the B is twice as sensitive to the B. So just think of the AB and BA as the two opposites, and just think of it as 2A and 0B, or B0, however you want to look at it. But it's twice as, the material itself is twice as sensitive, okay, to the A, and it's 0 sensitive to the B, and it converts B's into A's. So those are the 3 rules, or the 3 functions that are dictating what's happening. So you can sort of see that an A and a B goes in, the B is converted into an A, the A that affected here comes out, and so you have twice as many A's coming out as went in, and no B. And likewise from the other side. And these are exactly the materials that these two poles are gravitationally sensitive to. Well, it should be the other way around. Oh, this is just so, it's just sort of irritating that I think I just drew it backwards. Let me think. They're twice as sensitive to A's. That means they're pushed twice as much by an A. Yeah, so they're pushed apart here. So this ends up being a high pressure of A. They're very sensitive to A's. A's make them move the other way from an A there. A is gravity to them. So it's the opposite of gravity in the sense that we're getting pushed down. So we have the perception of gravity being a pushing you toward force, but it's really a repulsion force. It's the force above us that's pushing us. So you have to understand that it's gravity in the sense that it's gravity to the object facing it. It's pushing force. So the blue sections are more sensitive to the red gravity in the sense that it will move them in the direction of that red. So here's the repulsion of the two poles. So now we basically can see that the gravity has been essentially doubled, where in normal circumstances there would be half gravity here. In normal circumstances, the gravity of these two objects would shield each other from the gravity, and their shielding would create a lower pressure here, and they'd have more pressure here because they'd be shadowing each other. So under normal gravity they're being shielded, but because they're twice as sensitive, they're producing 1 times more. So the net effect, you could argue, that their gravitational attraction is one component of their interaction with each other, but because they're twice as sensitive, now they have double gravity. So now they have an extra gravity that's pulling them together. That kind of thing. Yeah. So you can sort of get the idea, I think, from this drawing that that this is like this number, this 2x number could be 5x, it could be 10x, it could be 100x. So you have to understand that that's why gravity and magnetism, gravity seems a much weaker force, but it only seems like a weaker force because we're only being affected by a certain percentage of the gravity, a tiny percentage, and magnets are sensitive to a much larger percentage. I just doubled it just to make it an easy computation, but this, like I said, this number could be 2 million. It could be that this substance is highly influenced by A gravity and not influenced by B gravity, or just normally influenced by B gravity. But the key point is that it changes B photons into gravitons. Let's call them gravitons, and then I won't get confused. It converts B gravitons into A gravitons, and it is sensitive to A gravitons at some proportionally large number in terms of making it magnetically significant. Now maybe we just sort of stick with the 2 number. I don't know. Now we just get dangerous in terms of, well, then magnets would be more gravitationally influenced if they were converting more of those A's. So I'll have to, stuff happens, and it makes you think, and then you say, wait, I got to fix that. So we'll just leave it as it is for now and make the argument. So the thought that's coming to my mind here is that there is a significant difference between the gravity between two. Like, we see very little gravity. I can put 2 bottles next to each other and they don't slide into each other, so gravity doesn't have any influence. And it does have a lot of influence with magnets. Magnets are very powerful. The force is magnified somehow. And so I'm not accounting for the magnification of the gravitational, the amount of gravity being created, the amount of gravitational pressure. And but I think that just has to do with maybe I have to switch which one's doing the converting. Maybe. is that would account for it then. So if we just switch that A's aren't converted, I mean B's aren't converted to A's, but that A's convert to B's, and then we just switch the magnets, you know, the proportional numbers would be just the opposite. So I guess that's where I have to change one of the fundamental arguments here. I don't know whether I should just redo this video with the change. Well, I think it's I think it's good enough. Yeah, I'll do it again and deal with that issue. So I had a choice, and I just didn't know what, you know, I just chose to make the B's converted. But it seems more likely that the B's are just invisible altogether. Nothing happens to them at all. The A's are the ones doing the converting. And this would be BA, and this would be AB then. I don't think there's any other way I can switch that. But it doesn't really matter which one's doing the converting, but the important element would be is that if it's more sensitive and it's converting and creating the same thing it's more sensitive to, that would make more sense. So this is really twice as sensitive to B's, but it doesn't convert B's. And the A's, it doesn't it converts them. Yeah, well, whenever. Yeah, I'm going to have to do it over again. Damn it. But anyway, I don't think I can make this conversion right. Like I said, I just chose it arbitrarily, you know, just for the sake of argument. I knew there had to be one part of the filter that it's invisible to for the other part to be twice as much, right? So, I mean, because you have to keep it gravity neutral. And the only way but in this context you can keep it gravity neutral as long as the new thing being created, the extra gravity, is of the right type of gravity. The kind that it's sensitive to rather than the kind it's insensitive to. That's the tricky part. It seems unintuitive. That's why I did it wrong, is because it's intuitive to do it this way, but it's the right answer is probably the other answer. So anyway, it doesn't. Alright, so this will have to just remain imperfect again. Damn it. You know, I really thought I had it done. I mean, well enough done. And now I'm going to have to do it one more time to explain the intensity of the magnet, the fact that what magnets are doing, right? They have a kind of an interesting word, magnet, because they're magnifying gravity. So that's probably a concept I'll have to keep that I'll have to keep mindful of. And but they're magnifying it in such a way as they're not changing their actual sensitivity to gravity. They're only changing each other's sensitivity to gravity. So they're only creating extra gravity in a proportion consistent to what only other magnets are going to notice. For the field itself will remain the same in terms of the total gravity. They're just changing the amount that each other is sensitive to. Yeah, which this explains well enough. So, anyway. Alright, well, we'll leave it there. I'm partially satisfied. At least it's got color, so we're getting closer to a better model. But like I said, it is hard to model magnets in 2 dimensions. I think that's enough. Okay, I'll let it go there. Do better next time, blah, blah, blah.